So we're back in Needham this week, and last week we were talking about insulation as well as our interior vapor control layer, which is our siga. We also talked about the blower door test. If you want to see that, revert back to last week's episode. But this week we're doing Blueboard and Plaster. So what you see in here, this is actually the future pantry. And on the wall, I'm going to explain to you what that is in a second, but you can see them working on the ceiling. And a lot of times they were doing the ceiling first because it's all overhead work, and that protects the walls from getting any plaster from coming down and screeding onto the wall. Why we do plaster? It's just what we do here in Eastern Massachusetts. It seems to be a Massachusetts thing. A lot of you guys that watch this are all around the country and you're doing drywall. Some of you guys might reference a level 5 finish. This is different. Drywall is basically a gypsum board, but then you're using a joint compound on top of that, which is usually going over some screws as well as seams, oftentimes using paper tape as well. And then those level 5 guys, what I've seen is they'll take a roller and actually roll a joint compound along the whole surface and then go back and sand it. Blueboard and plaster is different. Blueboard, number one, it's very similar to drywall in the sense that it's a gypsum board with a paper face, but it does have a different paper on it, which is designed to absorb the plaster. Now we're doing a traditional 1 coat here, not a 2 coat, which you've seen in some other projects, and it starts with a scratch coat. So you can see here, we have our mesh tape, and this is considered our first kind of scratch coat over any of our seams. These areas where they're bigger scratch coats, essentially going across bigger portions of the wall, is if we have a wall that needs to be built out further than what would be kind of like an 1/8 of an inch veneer coat. So they'll go through and hit the low areas, make sure that they're getting those areas filled. Then they'll go back and then they'll actually screed across the entire surface, and that's going to be our veneer coat. So it is a plaster base, and that will get screed across the entire surface with a 14-inch trowel. And at that point, what happens is kind of like concrete. You're gonna set it on the wall wet, and as it's drying, you're gonna go back and you're gonna continue to burnish it. You'll burnish it all the way to a really smooth finish, and that smooth finish is essentially prepped for primer. What's different about drywall and plaster, a couple things. When this stuff is done, it is moisture curing. There is a tremendous amount of moisture in the home, so humidity levels are pretty high, and the pH content is very high in this plaster. So even though it might look dry or it might be dry, you actually have to go back and then test the pH level to make sure it's prepped and ready for primer. If you paint this too soon, the moisture trapped in that will actually cause the primer to fail. One of the big differences between drywall and plaster is the drying time between finishing plaster and going into paint. So what's really important is to make sure that you have enough time built into your schedule for this stuff to truly completely dry out, and again, test for that pH level. Another thing about that pH level, or even just the humidity in this plaster, is that when you start installing trim or any material that's on the wall, you have to be considerate of the fact that the wall has moisture in it, and it's drying by pulling that moisture out through the surface. So if you're installing millwork or paneling or interior trim on raw plaster, the likelihood is you're gonna actually pull that moisture into the wood. And I can tell you about a mistake I made about probably 8 years ago at this point, but we had finished all plaster. I let it dry for a couple days, and then I trimmed the whole house with raw poplar, painted it, we finished the job. 6 months later, all of the poplar trim actually had this like grain raise on the surface, and that was because it was sucking the moisture out of that plaster. So as far as what I would recommend there is that you either prime the walls prior to installing trim, or you're gonna have to use a pre-prime material, or for belt and suspenders, use pre-prime material on a primed wall. So this is really a big milestone for us. A couple of the other details I want to point out is that you're going to see these metal corner beads. That's pretty typical, just like the mesh tape. This has a mesh flange that gets stapled to the Blueboard, and they can actually build this out and make sure that this is plumb and level where needed. But when we get into our elliptical arches, they're actually switching to a Trimtex profile that's designed to go around that. And they know how critical that this section is to be flat, so they're going to fill that with some additional mesh tape. You can see right here, essentially this Trimtex profile is a flange on one side that's continuous, and then on the other side it's snipped, almost as though if you had scissors, which gives you the ability to go around curved surfaces. So you're gonna see that in any of these archways, and upstairs we'll actually have some areas that are already done. So we'll show you that. These archways, just a reminder, these are actually made by Archways and Ceilings. Extremely efficient, extremely inexpensive when you consider how many archways are in this home. Just from an opinion standpoint, rather than a traditional arch, the elliptical arch is really nice because you get that curved look, but it's kind of shrunk down and not so tall looking. There's other parts in this home that actually aren't plaster. So you saw the beams that we were installing last week in the entryway and that hallway, but now I'm standing in the kitchen. In the kitchen, the guys have went ahead and installed the beam. And just a reminder of what we got going on here, we have these rough sawn hemlock beams that the guys went through with a wire brush and basically pulled all the loose material off it, really exposing that grain for future staining. And then they screwed those plywood backers on top of the beam prior to lifting the beam up, and then they push that beam up into the ceiling, and those plywood backers are screwed and glued to our eye joist, essentially supporting that beam up on that ceiling. Now, what they're working on now is we've worked with our CNC guy, and we took some MDF panels, ran a V-groove bit through it, and essentially created this V-groove ceiling out of sheet goods. Now, some of you guys are gonna say, well, hey, you can buy that stuff right off the shelf. You're absolutely right, and unfortunately, our vendor was out of stock and didn't have a delivery date for us. So that's when we phoned in a favor with our CNC guy, Barney and Carrie over in Avon. They were able to take MDF sheets and run this stuff for us and get all of this stuff turned around in a quick time frame so we could go ahead into the install. Now, if you look over here, the guys are going as far to prime the back side of the panel, and I'll explain why in a second, but they're also priming the edges. And the reason they're priming the edges is because the beams actually have a rabbet in them. So if you look up here, that panel actually slides into the rabbet, and then once it's all the way over, they're able to kind of pull it back and get it to rest on top of this rabbet here. The consideration, and maybe one of you guys are gonna say, well, why wouldn't you just do the whole ceiling with V-groove, put the beams in after? That's a fair way to do it. Using solid beams, we did not want to have fasteners through the beam or through the bottom of the beam or driving up. So instead we decided to make sure that those beams were really secure prior to getting the paneling up, and we're able to slide that panel up into that rabbet and then back. A little time consuming, but a great product. The reason that we're back priming these panels, when you're talking about something like MDF, you want the surface tension to be the same. And what I mean by that is whatever you do to one side, you want to do to the other. Now, the reality is this is going up into a ceiling and should really never see an issue with that. What happens with changing the surface tension is that if you paint one side, if I were to paint this one side here and just leave it, essentially this panel would eventually kind of shrink into a cup shape. By back priming it, you're keeping the balance on both sides of that panel. The paneling here is in the kitchen with these beams, and we also have it going into the living room. Now, the living room actually has these really big trusses. That's gonna be a project that we're gonna be getting into here in the next week or two. Those trusses are 8x8 solid material. We're gonna fabricate them here and then lift them up. Last week, a lot of questions came up about the installation. Even had a gentleman reach out to me about 7 in the morning and kind of question some of our installs. The tone of the voicemail is that we did a lot of things incorrectly. So I went back to the guys at Rockwool. We sent over the video that we shot on YouTube to our team over at Rockwool, and we had said, hey, can you assess the install? And they've actually been on site for a lot of the install for all this material. The comfort board that is underneath our slab, the comfort bat that is in our walls for thermal insulation, as well as the comfort bat that's in our walls for our acoustical insulation. Now, based on that and based on what they've seen in person and in video, they told us this is a level 1 install, meaning there's minor imperfections and this is done extremely well. And so the feedback that we got from that one gentleman, I'm sorry to report that we believe that you are incorrect, but either way, we appreciate the support watching the video, and we're gonna continue doing our thing here. So hopefully you tune in to the next episode.